engineer. And then I realized that I had an interest in machine learning. So I went to do a master's in machine learning, and then I wanted to apply machine learning to business problems. So what I did then was I applied for a business school. So I went to a business school to start a PhD in what's called operations management, but with the idea of applying machine learning to business problems. But that turned out to be very difficult. Not a lot of fields at the time are that open to machine learning approaches. And I think even now it is quite difficult to align machine learning with other parts of a business, such as operations, marketing, human resources, etc. Okay, but as people got more and more interested in data science and machine learning, I actually ended up with the opportunity to to continue my PhD at the University of Amsterdam in applying machine learning to business problems. But during this time, so my PhD was funded by a company. So what I was also doing was working on various commercial projects for that company. But also, that was when I got very much interested in Kaggle competitions. So from 2015 to 2018, I competed in over 30 Kaggle competitions. As you can see below, I earned 9 gold medals, won a few competitions. So, the goal of this talk is for me to, I guess, more importantly, share with you guys the value of doing Kaggle competitions, how it helps you in data science in your career, but also share with everyone some I think, important skills and tricks to performing well in competitions. And to be honest, winning competitions is really just taking those same approaches and applying it as much as possible, and then hoping to get a little lucky. Okay. So the first part of the talk today will be about demystifying Kaggle competitions. I remember when I just finished my master's, I had knew about Kaggle through my university courses, but I never really was open to competing in competitions. And one of the reasons was because it looked very hard. People looked very competitive, and I didn't feel like I had the necessary computing resources to do these competitions. So I didn't do that. And looking back, I think that was a mistake. And I also think that's a mistake that most people make now as well, especially people who are students working on their master's or PhD degrees. So I'll try to take a substantial amount of time to explain to everyone how that's the wrong mindset and how Kaggle can really help, and actually how you should be able to do very well regardless of where you are in your career. Even if you're just a master's student, you should be able to perform very well in competitions using the knowledge that you know already. Okay? And the second part of the talk is providing a framework to achieve excellent performance in Kaggle competitions. And finally, there will be time for questions and answering afterwards. So I think a lot of the times, what I'm curious about is what people think of Kaggle. Okay, so this was from maybe 2-3 years ago, but Kaggle kind of frames itself as a platform that makes it easy to connect companies' data with data scientists. So they claim there's a community of over 1 million data scientists on Kaggle who are there to help solve difficult problems for companies. And also companies can come on Kaggle by hosting competitions and then recruiting some of the competitors for their data science teams. And to be honest, I think that's actually quite accurate regarding what Kaggle really is. But one more thing on top of that is for aspiring data scientists, Kaggle is a really great place to learn. For example, with competitions, a lot of people will post their approaches, their solutions publicly on the Kaggle platform, and anyone can just go and learn from those solutions or even download it and use those solutions themselves. So here's a list of some of the people whom I had the pleasure of competing against during my 3 years of activity on Kaggle. So for example, here we have the first person is Zgiba. He's from Brazil, And before doing Kaggle competitions, he was working as an automation engineer for a petroleum company. He self-learned machine learning through a combination of open courses and Kaggle competitions. Now he is working as a data scientist at NVIDIA, which is the company that makes the GPUs. And before then, he was working at Airbnb. Okay. So through his Kaggle experience, he was able to get really high-paying top data scientists or machine learning engineer jobs in Silicon Valley. And he's actually from Brazil, right? So he's not from the US. He's never been to the US before, but yeah, he was able to get hired. And actually at the moment now he's working back home from Brazil, but working for a Silicon Valley company. That's this person here. Then we have Marios, who I think was doing his PhD in the UK when he got into Kaggle competitions. And again, you know, he's one of the top performers on Kaggle. And then afterwards, he's currently working as a data scientist at a company called H2O.ai. I don't know if any of you have heard it, but it's a company that builds tools for machine learning, and also has this thing called Auto ML, where it will kind of tune various model parameters for you, kind of just automatically. Okay, and there's a few other of these competitors. For example, we have Carlos, who is from Mexico, and his Kaggle experience helped him get nice jobs in the US as well. And he's currently working as an applied scientist in Amazon. And then we have, for example, Vladimir. He's from Russia, and he was doing his PhD in physics when he was doing Kaggle competitions. And then he eventually, he's currently a senior computer vision engineer at Lyft. He was working on their self-driving cars. And then we have Jung-Yoon, who is from Korea, and he's currently working as a senior research scientist at Netflix, and Tom, who's now at DeepMind. So as you can see, there's a large number of these Kaggle competitors of mine who are now holding really, really top jobs in the machine learning, data science, AI industry. So to give you guys some more information, right? What has Kaggle done for me personally? So remember, I did Kaggle competitions from 2015 to 2018. So it was about 3 years. Now, I worked very hard. I spent maybe 10 hours a day doing Kaggle competitions 7 days a week. So it was very demanding in terms of time, but I also learned a lot and was very interested. Okay, so through these competitions, I was able to win a total of $35,000 US just by winning some of the competitions, where earning second or third place in these competitions. I made many friends, so those are the people that you just saw earlier. Yeah, I mean, I consider them my friends from Kaggle. It also helped me get industry job offers. So, over the past few years, I've had multiple job offers as a data scientist. And to be honest, the interviews were quite easy for me. Oftentimes, data science interviews, involve doing like a take-home problem for maybe 2 days or a week. And I find these problems to be very easy to do because I have very strong Kaggle competition experience. So most of the strategies that I use for competitions, I can apply to these take-home assignments and do a fairly good job. And it makes it a lot easier to get good data science jobs. At least it has been very helpful over the years. It has also helped a friend of mine get a job. So during my PhD, I had an office mate. He was also doing his PhD, and towards the end of his degree, he decided to do a Kaggle competition with me. Together, along with a few others, we ended up getting 10th place in the competition, so we got a gold medal. And when he was interviewing for jobs, he was interviewing for data scientist positions. His employer was actually very impressed that he got a gold medal in a Kaggle competition. So it really helped him out in terms of getting his job. And I think for a lot of companies, having strong Kaggle experience is a significant positive, and it's something that people care a lot about. Well, what else has it done for me? Actually, it turned out that my Kaggle experience helped me get an academic job. So currently, I'm an assistant professor of business analytics at the University of Hong Kong. And in 2019, I applied for maybe 150 different academic jobs. And a lot of universities, they were very interested in me because of my Kaggle experience. Now, I'm not the strongest researcher, but because these days there's a strong demand to teach machine learning courses, especially machine learning courses that are more applied in nature. My Kaggle experience really helped in terms of getting the job that I'm currently at. It has also helped me get other opportunities, such as consulting projects and research projects. So one thing that's really been helpful for me is much of my research is applied, and it's working in collaboration with different companies. And when companies decide whether to work with a university professor, oftentimes they're concerned about whether the results could be beneficial to the company, not just an academic project. And because I've done a lot of Kaggle competitions, companies are much more willing to work with me on research projects, especially when they don't have the necessary machine learning skills to solve the problems. And it has been very helpful in me getting these opportunities to work with these companies. And finally, it brought me here today, right? I have been giving this talk to many different events to many groups of people, and it's really enjoyable for me. And if not for having done these Kaggle competitions, I wouldn't be having this opportunity. And most of all, it was the most 3 fun years of my life. Doing Kaggle competitions was a lot of fun. It can be challenging, but at the same time, one really nice thing about it is that you get to see really good feedback when you do well. When you do poorly, you also see feedback. Whereas, in many other types of problems, you might not be seeing the feedback. And here, this is a really big advantage in Kaggle. So I think one thing I really want to make clear to everyone is that although I personally enjoyed doing Kaggle competitions very much, and I think many of you have thought about it, but there's a lot of negative press or negative sentiment about Kaggle competitions that are on the internet. And I think it's rather unfortunate because I would say most of these negative sentiment is misplaced. So, for example, here we have a particular blog post by somebody named Pranay Dave in 2018. He wrote a post on why Kaggle will not make you a great data scientist. So first of all, I will tell you that what he's saying is wrong. Okay, at least that's my own opinion. But let me kind of give you some explanation as to why I think that's the case. Okay. So in this particular blog post, he makes certain claims. So the first claim he made is data science is not only about prediction. Okay. So for example, many companies are interested to know, well, what are the common paths to customer churn, right? So the goal is, well, these companies, well, their customers might leave them, and they want to know why. They want to know what's causing this to happen, right? So this is not necessarily a prediction problem. However, what prediction allows you to do, so first of all, keep in mind that Kaggle competitions are almost always prediction problems, okay? So you're given a data set, you're asked to predict something, and you build models to find the best possible predictions you can find. So in real life problems, what prediction allows you to do is it allows you to extract useful features that can generalize to a large data set, okay? So think about this. Let's imagine that there are a large number of different paths that customers take, okay? So how can you summarize the customer behavior when you have an exponential number of paths, right? Even if you know the common path to churn, you don't even necessarily know how to prevent it, right? But what you can do with predictive modeling is you can build a model to predict churn, right? And then the features or the variables that go into making these predictions are information that you can extract to help you gain insights about what is causing churn, okay? And of course, you can even try to predict it and then prevent it, okay? So if you can predict whether a customer is likely to churn in the future, then you can finally try to prevent it. So no, data science is not only about prediction, I agree with that, but if you can do prediction extremely well, it will help you out a lot when solving other data science problems, okay? A second claim is you will not develop skills on graph algorithms. So some real-life problems are graph-based. So, when you are working on Kaggle competitions, you cannot learn about things like page rank, modularity, shortest path, eigenvector centrality. Okay, but first of all, let me ask you this: does it really necessarily matter? Well, we're not sure. Okay, so graph algorithms are academically interesting, but to what degree are they practically useful? That's not clear. Moreover, it turns out that there are Kaggle competitions where graph algorithms actually play a role. So there's a competition called Quora question pairs, where the goal is to predict whether two questions on Quora are asking about the same thing. Now, you may not think there's anything related to graph algorithms here, but it turns out that this competition was set up in a way where graph algorithms played the most important role in maximizing your predictive performance. Okay, so if you're interested in the details, feel free to kind of take a Google search on that competition, and you can read more about it. Okay, but really the truth is this: graph algorithms are descriptive. They're there to summarize a graph. Okay, but what are we going to do with summaries? Well, it turns out that Google, for example, they use PageRank as a feature in predictions, right? So oftentimes, what we're actually doing with these graph algorithms is we're taking the summary from these algorithms, and then we're applying it to a prediction problem. Okay, so if you're good at making predictions, at the very least, you know how to use the graph algorithms, at least the results of the graph algorithms. Okay, so keep in mind, you may not learn about graph algorithms specifically doing Kaggle competitions, but you might learn how you can be able to use the outcomes of these algorithms anyway. The third claim is that you will not put effort in algorithm explicability. Okay, so these days it's very common to learn about explicability, explainability, fairness, etc. Right? So for example, people who got rejected for credit applications, in some countries by law they have a right to know why the application got rejected. Okay, so if you just care about making the best prediction about whether you should reject somebody's application or not, then that might not be sufficient. You might want to be able to explain why. Okay. However, this question is much more philosophical in nature, right? And it has to do with a trade-off between model complexity and correctness. Usually, these complex black box-like models, they are going to be more correct. So when you're trying to predict whether somebody will default on their loans, do you really want a model that is easy to explain but makes 5% more errors? Maybe, right? Maybe not. If you care more about getting the correct prediction, then you probably want to use an algorithm that's more predictive, okay? And perhaps algorithm explicability is not that common in Kaggle competitions, but at the same time, in order to do these problems extremely well, you do also have to do a lot of work with understanding your algorithms and seeing how they work on a manual basis in order to improve the models. And from there, you can also learn more about explicability. Okay, so there's a lot more information that I have in the slides that I'm not going to be talking about just for the interest of time. However, at the end of the talk, I will send the slides to Rhi, and then she can share it with all of you. Okay. So one other thing that somebody else had wrote about is 5 reasons Kaggle projects won't help your data science resume. And I think this is actually very, very wrong. Okay. So first of all, their claim is it's hard to stand out. Given that there are thousands of other people also doing Kaggle competitions, it's becoming harder and harder for merely working through them to be enough to differentiate you. And I would say, okay, that's true. You shouldn't just work through Kaggle competitions, but instead you should actually try to perform well. However, what's really interesting is that if you know what to do, and I will explain that to you in the second half of this talk, right? You can spend very little effort and get very good results in Kaggle competitions. I would say it's very easy to get top 10% in any competition just by spending 2 hours a day, okay? Something like 5 to 10 hours a week. It's not hard to do, and I'll explain how to do that. And if you're able to kind of follow through with a competition by doing that, I'm pretty sure you'll be guaranteed a very good finish. The second claim is that you'll only demonstrate a partial data scientist skill set, okay? So of course, we all know that much of a data scientist's time is spent extracting, cleaning, and manipulating data. And perhaps working on an independent project where you can, showcase your skills, it may be more valuable than doing Kaggle competitions. But actually, that's not true because many Kaggle competitions do require cleaning and manipulating data. There are many competitions where you're using text data, many competitions where you're using image data. And here, you really have to make the effort to extract the data, clean the data, and manipulate the data. Okay, in order to do well, you really have to do these things at least fairly well. If you're not able to do these things, then you're not able to do well in a Kaggle competition. Okay, and also keep in mind that data science is hard, so don't force yourself to be a unicorn. And basically, the idea of a unicorn here is somebody who has all of the skills. Okay, you shouldn't try to learn all of the skills, but instead you should work with what you have. So if you don't have the opportunity to work on an interesting independent project where you can show off your skills, then perhaps doing Kaggle and being a rock star there is the next best thing. Again, there's a few more things that people have written that are negative about Kaggle, and I kind of argue against that in the slides. Feel free to look at it later when you have time. Okay, so let me talk a bit more about what I learned from Kaggle during the 3 years where I did a lot of Kaggle competitions. The first general thing I learned is something that I call data science rigor. Okay, so what is data science rigor? Well, there's this thing where in order to solve a prediction problem very well, you have to learn to understand the problem first. Okay, so a lot of the times, when you're going through university, you might learn about 5 different algorithms, right? You might learn about some problems such as information retrieval, or maybe bioinformatics, maybe natural language processing, computer vision, etc. Right? You learn about these problems from a technical perspective, but you don't actually understand the problem. And what do I mean by understanding the problem? Okay. Well, if you go deeper, you might think, what is the right evaluation function for this problem? Right? Because choosing the evaluation function will affect performance of the model. Usually when you're learning in university, you're taught, okay, I'm going to use root mean squared error, or I'm going to use log loss, etc. Okay, well, these are reasonable options, but it turns out that for classification problems, people prefer to use something called the area under the receiver operator curve, or the F1 score, okay, or a combination of precision and recall. For regression problems, maybe RMSE is a good idea, but also people like to use R squared and the Gini coefficient, right? So if you just know about problems from a technical perspective, you might not really appreciate what the right evaluation function will do to the performance of the model, but also makes sense for the actual problem that you're trying to solve. Okay. Another example is, how does, for example, time series affect the performance of the model? Okay, so if you're learning about time series in class, then you might think, well, okay, I have a data set where it goes in time. Maybe, it's something like demand, right? Demand is number of people who want to purchase a product over time. Well, that sounds like a reasonable problem. You might expect that information about yesterday will help me make predictions about information today. But if you're actually trying to solve this problem in practice, what you might get is something like 10 months of training data, right? And you have 2 months of test data. In this case, how should you validate your model? If you validate your models incorrectly, what will end up happening is you will build a machine learning model that doesn't generalize very well to the real life use case, which is predicting future demand. Okay, and I've experienced these kinds of mistakes personally when I work on Kaggle competitions. So I did one Kaggle competition where, because I did not set a correct validation framework for my approach, I had done all kinds of training and validating, improving my model, But then I realized that, oh, this is actually not improving my out-of-sample test performance. And that was very unfortunate, but this is very common in real life. And understanding the prediction problem means knowing how to solve these kinds of problems and not make these kinds of mistakes. Okay. The second thing I learned from Kaggle is generally what I would call the 80-20 rule of data science. Now, in research, we only care about coming up with a new solution to an existing problem. Okay, it doesn't matter if it solves the solution well or not. It's just something that has to be new and something that you can make a claim about solving the problem well. However, in real life, that is not the case, and in Kaggle competitions, that is not the case either. What's really important is if I describe to you a business problem, how fast can you design a data-driven solution? And by that, I mean, what should your target variable be, right? What data, what features do you need to predict the target? This is the information that's really important. It's not the research part of coming up with the next greatest deep learning model. It's actually coming up with some kind of a reasonable predictive analytics solution to a problem. So what you learn in Kaggle competitions is that you really don't have the time to waste on difficult things, right? So again, in research, we work on very difficult problems. We try to come up with very complex, fancy solutions, but chances are these things don't work really well. So in real life, you usually have 2 weeks to design and implement a good solution to any problem. And in Kaggle competitions, it's very similar. You have about 30 days for competition to beat everyone else. Okay. So what does this actually mean? Well, this means when you're making decisions on which ideas to try, you have to think, what are the chances that this particular idea will improve the performance of my model? Okay. You have hundreds of ideas to try. You have to start with what you think is most likely to work. You also have hundreds of models to try, but you should already know what works. And if you do Kaggle competitions when you're early in your career, then by the time you're maybe 3 to 5 years into your career, you will have all the solutions to any kind of prediction problem that anyone can ask you. Okay, so you won't have to waste 2 months trying to solve a problem, because you can just say, well, based on the data that you have, based on what you're looking for, we simply cannot solve this problem using machine learning. We should try something else. So you save the company 2 months of time, and that's also a lot of money. Okay, so Kaggle competitions really give you some personal experience with this 80-20 rule of data science, which is spend 20% of the time to try to get 80% of the performance, and don't worry that much about the last 20%. Leave that to the researchers out there. The third thing I learned from Kaggle competitions is the power of teamwork. Okay, so one unique thing about machine learning is that wisdom of the crowd almost always works. Okay, in that when you take everyone's best ideas and put it together, you will almost always improve whatever solution you have. So in Kaggle competitions, what ends up happening is teams of people, they'll get together, okay, and then they will combine their solutions. And that's what we call an ensemble method in machine learning. And every time I teamed up with another person, my team's performance improved. And every time my team brought in a new person to the team, our team's performance improved. And it's not like we work together that well with each other, but it's just that everyone have different ideas. And when we take each of our solutions, meaning each of our predictions, okay, and if we just take an average of each of our predictions, then the average of our outcomes tend to be much better than each of our separate predictions alone. So it turns out that the teamwork is really important in Kaggle, and when you do that well, you can improve your performance by a lot. Okay, and also, don't be afraid to ask for help. So, there are two unique cases that happened to me. So one time, I was doing a Kaggle competition, and there the goal was to essentially build something that acts like a search engine. Okay, so there's a US-based company called Home Depot, and they gave a problem where there are a lot of products and there are a lot of search queries, And the goal is to predict how relevant a particular product would be for the given search query. So when I was doing that competition, I was fairly new to natural language processing problems, and I was ranked maybe 40th place in this competition at the time, and I got stuck, meaning I didn't know what to do anymore. I ran out of ideas. Then I just sent a message to, at the time, the 6th ranked team, and I said, hey, I'm out of ideas, but I'm really interested in working with you guys. Would you be interested? And they were open to it. So I joined that team, and ultimately we finished in 2nd place. Okay. So even though I actually was not an expert in natural language processing at the time, and I didn't really know what I was doing very much, I was able to contribute to the team by working on improving how we ensemble results and working on other parts of this problem that wasn't necessarily directly related to natural language processing. So I was still able to contribute, and ultimately we finished in 2nd place and won $12,000. So this was really my experience with, well, I can't solve this problem by myself, but I can still help some other people do this problem better. Okay. Another case was in the Quora question pairs competition, where I was ranked first for a very long time, and then there were 2 others who asked if they could team up with me. Now, this time, I was already ranked 1st place. The 2 others, they actually hadn't started a competition, but because I knew about them, there were other people I'd seen on Kaggle competitions, I decided to agree to team up. So they joined up with me, and not too long after that, I actually ran out of ideas myself. I just didn't have any idea what to do next. But my teammates were really able to contribute after that, and they were able to help us finish in 5th place, even though if I was working by myself, I probably would have ended up in 20th place. So this was a case where I really benefited from other people working with me or other people joining me where I was doing well. So don't be afraid to ask for help. And then in the commercial settings, I've had situations where there were interns who had an interesting approach to a problem, and then I had another approach to a problem. We took our solutions, put it together, and we were able to make a nice improvement together like that. So this does generalize to real life problems as well. Okay. And finally, what I learned from Kaggle is that determination and grit is really the most important thing in data science. Okay, so many of the people who were ranked top 10 in the world in Kaggle, they did not start strongly. So earlier I showed you a few people such as Giba from Brazil. I mean, he started without any machine learning experience. And I remember when he first started doing Kaggle competitions, he wasn't doing very well. But after a few, he learned the tricks, he learned the skills, and then eventually he was improving. And then by the time I knew about him, he was already ranked 2nd place in the world in Kaggle competitions. Okay, he'd won many competitions. Just because if you just do 2 or 3 competitions, and assuming you have some basic understanding of machine learning, then you will all become experts, regardless of where you started. Okay, some people took many years before getting their first gold medal, but after you get your first gold medal, you basically learn how to solve these problems extremely well, and it does translate to your future career. And I think it's important to think, if data science is your career, or if that's the career you want, then you should think of everything you do now as an investment for the next 20 to 30 years. So, pick 1 or 2 things that you're passionate about and really just do it and work on it for a long time. Don't be afraid if things don't go well early. Just be persistent. So I think we were meant to have a break somewhere in the middle. So maybe now is a good time to have a break. Rui, are we okay with that?
Yeah. How long do you prefer to have the break?
I'm quite flexible.
Okay.
What's normal for you guys?
Maybe around 10 minutes. Would that be okay?
Yeah. So let's take a break for 10 minutes, and then I will continue with this slide when we get back.
All right. See you guys in 10 more minutes, around 8:45. Okay. See you then. Okay, so hopefully everybody's back from the short break. So we'll continue with the seminar, with the webinar. The floor to you, Qingchen.
Okay, thank you. So yeah, let me continue to with the Kaggle experience. I think this slide is probably something that's very interesting to all of you. And you know, just to kind of give you guys some a reminder, I actually did a complete master's degree in machine learning, where I learned about all kinds of models and all kinds of problems. Okay, and it turned out that almost everything I learned in school was useless in Kaggle competitions. And let me explain that a bit in more detail. Okay, so you know, first of all, what's your favorite prediction model? For me, it was what's called Bayesian probabilistic models. An example is hidden Markov model. Another example is latent Dirichlet allocation. Okay, so this was my favorite prediction model. And also, what else did I learn in school? I learned about linear regression plus regularization. I learned about support vector machines plus kernels. Learned about perceptron, AdaBoost, probabilistic modeling. And what was my takeaway from school? Well, the takeaway is that there are many different models or methods, and you should try different methods for a given prediction problem because you don't know what might work. I mean, all of these models seem to be amazing. They seem to solve all of the world's problems. So you might as well try all, okay? It turned out all of this is wrong. Most prediction models are developed and published based on academic novelty and mathematical elegance. Academics traditionally did not care how well a model predicts as long as it beats a certain benchmark, okay? And that benchmark is usually not carefully selected to serve as the best possible benchmark, but just something that seemed reasonable. Therefore, when I first did my Kaggle competition, I realized that everyone was using this method called gradient boosting. Okay, well, gradient boosted machines, or gradient boosted decision trees. And I had no idea what that was. I never learned about it in school, right? I did all the possible machine learning and AI courses during my bachelor's, and I did a whole master's degree in machine learning. And I didn't know this particular method that everybody was using. It turned out that this method was winning almost all of the Kaggle competitions, and even now it's winning at least a good percentage of the competitions. Okay, so if you have a problem that's not dealing with natural language processing or computer vision, then chances are this gradient boosting machine method is the best out there, because I mean, in competitions, this is what wins. Okay. And I never learned this. So, everything I learned in school was useless. But actually, that's not completely true either, okay? It also turned out that everything I learned was useful, but kind of at a different level. So when you do a lot of Kaggle competitions, you do realize one thing, and that's machine learning is for one purpose and one purpose only, and that purpose is prediction, okay? Now, you can do other things with it, okay? There's these things called you can build, vectors of or vectors for. Sorry, not vectors. You can build embeddings for products. You can build embeddings for customers when you're, solving recommendation systems problems, or you can use embeddings for this and that. Okay, but this is kind of a side result of machine learning. The core thing that machine learning is good for, the core purpose, is prediction. Okay, and what is prediction? Well, to predict well is to minimize some error between the predicted and true values. Okay, and about a model needs to be evaluated by how well it predicts. And these are the things where if you go through a university course and you go through the theory of machine learning, the theory of all of these methods, ultimately, this is the key. This is what machine learning is about, okay? So in real life machine learning, you're not going to think about these mathematical formulas of the models, but you have to understand the key concept, which is these are the important core purpose of machine learning, and this is how it actually works, okay? So, when you learn these things in school, it is actually useful. And that's why when I first competed seriously on Kaggle, I was able to win the first competition that I entered. Now, I worked probably as hard as everyone else, so 12 hours a day for about 30 days on that competition. But I didn't know that much initially when I started the competition, but I tried many things and I learned as I went. But this is because I actually had a lot of the basics down. I understood the theory of machine learning very well, thanks to my academic training. Okay, so what you learn in school is useful. It's just not directly useful. So it is still important to learn about these things through university. Okay. The other thing is that overfitting happens all the time. If your model is not overfitting, then it's probably not doing its job. Okay, and on the flip side, underfitting happens even more often. This is really scary because when you can overfit, you at least know that you're overfitting. If you're underfitting, you don't even know that you're underfitting. That's why the best performing models, like gradient boosting machines or deep neural networks, by default, these models are able to overfit the problem. Okay, you have to overfit the problem to do the best it possibly can, and then you look for ways to reduce the amount of overfitting that happens. That's how to maximize the predicted performance. And finally, the last thing I learned in Kaggle is definitely do not try to be a unicorn. Okay, when you are looking at job postings for data scientists or machine learning engineers, you will see that they're asking for maybe 20 different skills or packages, etc. And it's really impossible to know everything. Okay, so don't try to know everything. Understand the basic things that are required to be a productive data scientist. The first thing is, can you write code in a timely manner that works? And you will be amazed by how many people out there, they claim to be data scientists, but they really cannot write code in a timely manner that works well. Okay, so this is the first thing. You have to be able to write code. The second is, can you write code to process raw data? Usually in school, you learn, okay, I have this data set. I just need to implement mathematically a machine learning model, train the model, and make predictions, and I'm done. Okay. But in real life, you're given data of all kinds. You're given raw data, and you need to be able to write the code to process it. You need to be able to write the code to generate the features from the raw data. And again, there are many data scientists in the industry who are not able to do this well, and it does cause a lot of problems to the companies. Okay. Third, can you train, validate, and test models from known packages with reasonable performance? What I mean by known packages is, can you just use a open source machine learning package to train, validate, and test models and get reasonable performance out of it? You do not have to implement these models by hand, right? You don't have to implement your own logistic regression. You do not have to implement your own decision tree. As long as you know how to use it and to evaluate the models with any known packages, preferably open source package in Python or R. But if you can do that, that's good enough. Okay. And finally, do you understand conceptually how some prediction or statistical models work? Okay. So there's probably 20 different machine learning models. You don't have to understand all of them. But what you do need to understand is how some of them, maybe 3 or 5 of them that you use more often, how do they work conceptually? Okay. If you don't understand how they conceptually work, it's very hard to use it properly. You don't have to understand the details, but at least understand conceptually how these models work. For example, how does a convolutional neural network works, right? Don't have to understand the math, in my opinion, just have to know conceptually how it works so you can use it well in the future. So if you can do these 4 things reasonably well, then you're going to be able to contribute as a data scientist. Okay, everything else is a matter of experience. So when a job posting asks for 50 different skills, well, as you work in the industry, you will learn these skills eventually. But don't force yourself to know everything before you apply for jobs. Okay, so as long as you can do these 4 things, that's the important part. That's what's needed to be a successful data scientist. Everything else is just, I would say, wishful thinking by the hiring side. All right, so that was the first part of this talk. Now the second part is how to achieve excellent performance in Kaggle competitions. Okay. So getting started, for those of you who have not looked at a Kaggle competition before, I strongly recommend that you do. So just go on kaggle.com and then click on the competitions tab and look for like what's called a featured competition. So just click into it, read about it. You can then also sign up for a free Kaggle account in order to download the data and try things. Okay. But doing a Kaggle competition is actually very similar to solving many real-life machine learning problems. And here are the steps that you need to do in order to be successful. And if you can do these 5 steps throughout the whole competition, I can almost guarantee you that you will finish in the top 10%, okay, and likely earn what's called a silver medal in the competition. So the first step is understanding the prediction problem, okay? So if you start a competition, usually there's a description. Usually there's also a part about them saying what is the evaluation metric. There's the data set, and then there's some discussion boards on the about the competition. The first thing to do is to understand the prediction problem. What is the target that's being predicted? Okay, what are some of the data or features that are available, and why does the competition host, so the company that hosts the competition, why do they care about this problem? You really want to understand the prediction problem, because if you can understand it, then you will be able to develop a very good solution to solve it. If you're not able to understand the problem well, then it will be a lot harder to find a very good solution. Now, you can always find a decent solution, but to find a very good solution, you do need to understand the problem. The second step is understanding the data. Okay, so one nice thing about Kaggle competitions is that usually only a couple days after the competition starts, there will be some people who do an analysis of the data. So they'll do exploratory data analysis, and they will publish their code to do it on the Kaggle platform. So all you have to do is click into it and read their notebook, and then you will learn a lot about the data that you otherwise would not know. Okay, so that's usually what I do. I start by thinking about the prediction problem, and the second thing I do is I try to understand the data. I go through these public exploratory data analysis that other people have done, and I will then manually look at the data to try to understand it. It's also very important in real life to actually look at the data to try to understand the data before or while you're solving the prediction problem. The third thing to do is read the discussion forums. So in Kaggle, people will discuss the competition a lot, and they will make posts in the discussion forums. This is very important because if you join a competition that had started, let's say, 1 month ago, right, then there's a lot of things that has happened, and people discuss them in the forums. So in order to catch up to all the developments, you do want to read the discussion forums as much as possible for useful information. Okay, so this will help you a lot. The fourth thing is start with a public notebook. So as I mentioned in Kaggle, there is a public notebook tab for every competition. And when you click into it, you'll see that other people have come up with their solutions, and they have published it publicly. All you have to do is click into their notebook. You can read it, you could even run it, and you could even generate, using their notebook, a solution to then submit to the competition. You don't have to know anything, you just have to run their notebook and submit it. You will get the same performance in the competition as the person who wrote the notebook in the first place. Okay, and what's interesting is that because Kaggle is open source, right? People will continue to work on those public notebooks to improve it. So what you'll see is that as the competition progresses, the best public notebook is also improving in performance. And as long as you keep up with this notebook, you can always have a score or have a final result that is as good as this notebook. So if this notebook gets top 10% in the competition, then so will you. Okay, and usually the best public notebook actually gets top 10%. Okay, so you just have to follow the best public notebook to get top 10% in a competition. The fifth step right? So up to this point, you don't have to do any programming work on your own. You don't have to develop your model. You don't have to develop your own solution. Okay. Steps 1 through 4, understanding the prediction problem, understanding the data, read the discussion forums, read the public notebooks. It's all there, published for you. You can look at it easily. Step 5 is to develop your own solution. Okay. And the cool thing about machine learning is that if your own solution can surpass the best public kernel, so here I wrote kernel, this was the old term for it, now the new term is public notebook, okay? So if your solution can surpass the best public notebook, then you're guaranteed to finish in the top 10% and earn a silver medal. What's even better is that even if your solution is not better than the best public notebook, oftentimes, if you take your solution, take an average of it with the solution from the best public notebook, then you will be able to surpass the best public notebook just by how ensembling in machine learning works. Okay, so as long as you do a reasonably good job with your own solution, then if you average it with the best public notebook, you'll do better than it, and that will almost guarantee you a silver medal. So I didn't mention earlier, but like I had done many competitions where I only had about 1 week to work on it, so I didn't have a lot of time to work on it, but I was still able to get silver medals because I had a solution that was about as good as the best public notebook, and I take an average with it, then I surpass the public notebook, and that earns me a silver medal. And that's what I suggest every one of you to do if you want to, start Kaggle, start competing on Kaggle. Earn silver medals. Silver medals are actually quite, people will look at it, people will be quite impressed even with silver medals. And you can do that without knowing anything about machine learning. But I do recommend that, of course, you go through other solution and try to learn it as well. One other thing about about Kaggle competitions is that even when a competition has ended, you can go back and do the problem on your own. You can read the forums, you can read the public notebooks, they're all there. And sometimes people who get like first place, they will also publish their solution as well. So you can even download their solution, run it, and see how it works. So you can learn a lot from past competitions, a lot from other people's work. And that's something that's quite unique, right? It doesn't exist anywhere else. So these days, I even go back and try to learn things from Kaggle competitions. So, recently I've been trying to learn more about computer vision. So I go back to past computer vision competitions and try to learn and understand what other people did in order to do well, even though I'm very new to that problem myself. So let me give you some more detailed examples on things like understanding the prediction problem. So for example, you might be using high-resolution lung scans to determine when lesions in the lungs are cancerous. So essentially, you're trying to predict based on lung scan images whether the lung is cancerous or not, right? Maybe you're predicting how expensive a car insurance claim will be, predicting faulty products from manufacturing lines, predicting the relevance of search results, predicting telecommunication network faults, identifying who are likely to get cervical cancer, predicting whether two questions are the same, predicting stock returns, forecasting sales at retail stores, predicting price of products, answering exam questions, right? So there's all kinds of Kaggle competitions, and these are the different, problems that these competitions are about. So this is what I mean by understanding the prediction problem. For example, if you're predicting how expensive a car insurance claim will be, right, that will give you some ideas on how to design relevant features to make these predictions. It will give you some ideas of which models will work well. Okay, so that's what I mean by understanding the prediction problem. Then you want to understand the data. Usually there are 3 types of Kaggle competitions when you think about the data. One type is that data is in a single file. Okay, so they give you the data set in a single file. It's an n by n table with anonymized columns. This is very common. The advantage is that it's very easy to get started with these competitions. You almost don't have to do anything. You download the data, write 3 lines of code, make predictions, submit, and you're done, right? So it's very easy to get started. The disadvantage is that, first of all, because the data is just one table, the columns are anonymized, it's very difficult to be creative, to come up with new solutions. And also, because it's very easy to get started, there's a lot of competition. These days, for these types of competitions, there are easily 8,000 people competing. Now, keep in mind, out of the 8,000 people, I would say 7,000 people are just there to try it. They're not seriously competing. So if you seriously compete, and then just by keeping track of the best public notebooks, you're definitely going to get in the top 1,000 of that competition if there are 8,000 competitors. So you don't even have to do any real work to achieve that. The second type of data is that data is in a single or a set of files. Okay, the column names are provided. The advantage is that it's still fairly easy to get started, okay, and there's some room to be creative. So, for example, you might get 3 data sets that you have to put together, and the column names are not anonymized, so you have much more freedom to construct additional features or try things based on the information in the data set. Okay, so this is actually quite a lot of fun, but the disadvantage, though, is that there are also a lot of competition. These competitions are fun, fairly easy to get started, so a lot of people will try. But again, if there's 8,000 people competing, usually 7,000 are just there to try it. The other 1,000 are actually trying to compete. Finally, you have data that's in an unstructured format. So they could be images or unstructured text. The advantage there is that you have the freedom in how to put the data together, and there's weak competition. Usually there's only a few hundred, maybe 1,000 people competing in this competition. Of course, the disadvantage, though, is that there's a high entry barrier to get started. It's not easy to work on problems dealing with images or unstructured text, often because the data set is very large, but also because before you can even solve the machine learning problem, you have to do some engineering work to construct the data, right? You have to take the images and convert it into a format that's relevant for machine learning, same for text. So it is a little more challenging to get started, but the nice thing is that usually for every competition, people will very early on post solutions to get started, and you can always start based on what other people had posted. So what I mean by reading the discussion forums is, for example, here is a screenshot of the forum page of a particular competition. And you can see here, for example, the second topic is called shuffling the features. So clearly here, there's a discussion about whether the features should be shuffled. The third thread is how come they are stuck at 0.924. Again, there's a discussion about this particular score in the competition. And then the fourth thread is var12 and var81, which is saying something interesting about these two particular variables or features in the data set. Okay, so when you're in this competition, you will want to read more about it in order to understand what's going on, to catch up with everyone else. People will actually publish certain tricks that they found in the data set that they think, okay, well, I should let everyone know. So they'll kind of release that publicly, and then everyone can learn from it or use it. This is very important because otherwise, sometimes, if you find a cool approach and not tell anybody, then you're doing better than everyone else, right? But on Kaggle, a lot of times people will share information. And here's a screenshot of how public notebooks work. So again, this was an older screenshot, so you can see that the tab here is still called kernels. Now it's called notebook. But if you go into the notebook, you'll see that there are a list of public notebooks. And for each notebook, there's a name that kind of explains what it does. But also there are sometimes these tags that would say, that would show the performance of that particular notebook. So for example, the fourth notebook here that says XG boost, there's a number to it, which says 0.89. So that means this particular notebook will get a score of 0.89 on the leaderboard if you were to just run it and then submit its output into the competition. It will give you 0.89, right? And the notebook below it will give you a 0.9 score in the competition. So all you have to do is you go into a competition, go through the notebooks, look for the one that gives you the best score, read it, run it, submit it, and there you go. You now have a score in this competition that's equal to the best notebook. And then you can improve, you can try to improve your models based on that notebook as you go. So that's typically what I do. So here, if I clicked into a notebook, you can see that, well, this is Python code. It is 32 lines. It's actually quite simple. And this is a notebook, I believe, that gets 0.89 score on the leaderboard. And for me, actually, I learned a lot from other people's work because so when I first started writing code in Python, I was actually writing code in the style of Java. And by reading other people's code in Kaggle competitions, I learned all those cool tricks that you can use with pandas for data processing, all the cool tricks that you can use with sklearn on data pipeline building or prediction and prediction, then evaluation, and testing. So I learned all of these things through doing Kaggle competitions, and more specifically, though, through reading other people's code. And you can do that just by going into the public notebook, reading what they do, running it, and then trying to understand it as well. Okay. So here is my last slide, and it's essentially something that says like in 2015 I did a competition that was my first real Kaggle competition, and I got first place. However, if you were to revisit that competition, okay, if you were then to take the best public notebook, run it, and then build a very simple random forest model, okay, train a very simple random forest model, run it, and then take an average of the predictions of the two models, then you will end up getting something like 80th place in this competition, which would be the top 4%. Okay, so you didn't really have to do that much machine learning. You just do a little bit, train a very simple random forest model, then combine it with the best public notebook, and that would give you a top 4% finish. So, I mean, this was from 6 years ago, but even with recent competitions, this approach still works. So as long as you pay attention to the best public notebook, meaning don't just start a competition and leave, but actually follow through with parts of the competition as you go along. If you're able to do that, then you're almost guaranteed to get a very nice finish eventually. Okay, so this is all the slides that I have, and thank you everyone for attending the webinar. I'm happy to answer any questions that anyone has at this point.
Anybody has any question, you can either type at the chat box if you don't have any microphone with you, or you can actually use your microphone and talk directly with Qingchen. Well, in time, while we wait for our audience to maybe write their questions, I have a question for you.
Sure.
Okay, so when you mention about using the public notebook, and then submitting it, it sure sounds kind of like counterintuitive as to how Kaggle decide on the winner, because it's like everybody's working on the best public notebook. So how does Kaggle actually choose the winner?
Well, usually the best public notebook will only achieve performance that's in the top 10% or so. So everyone else have solutions that are better than the public notebook, and that's where the difference. So usually, right, the difference between first place and 10th place is not very large. It's maybe the third or fourth decimal digit. But typically, to win a competition, your team needs to have some idea that nobody else thought of. So it's very hard to win. It's very hard to get top 10, finish in the top 10. But this is when you spend a lot of time to try to figure out the details of what are certain things you can do to improve your model, to improve your predictions, try to learn from the data, try different modeling approaches. But I wouldn't expect everyone to always finish in the top 10. I would say top 10% would be reasonable. But at some point you run into a competition that you really enjoy, and maybe you get lucky, and then you end up in the top 10, or maybe even getting first place.
Wow, that's good. Okay. Well, any questions from the floor? How about another question from me?
Sure.
What sort of creative things that you can actually do, or that you actually did during the competition that you've gone through?
Yeah, so I can tell you about a few cases. For me, there was basically only one creative thing that I did that actually worked. I mean, you try many ideas, but most of them fail. The one thing that worked for me was sometimes there are problems that look like regression problems. So they ask you to predict the number of something. So maybe the number of inspection failures that a house would have if they were inspected. But it turns out that so everyone treats this as a regression problem, but the target can be 0, 1, 2, 3, 4, 5, 6, maybe up to 60. You can also actually treat this as a classification problem. Mm-hmm. So you can say, well, let me try to predict if the number of hazards would be, let's say, greater than 1 or not, right? And then greater than 2 or not, greater than 3 or not, greater than 4 or not. So what I did was, instead of using a single regression to solve the problem, I converted it into like 60 classification problems. And then for each of the classification problem, I make a prediction, and then I would recombine the prediction back together. And it turns out this is it works very well on some competitions. And using this approach, I was able to win first place in a competition, get fourth place in another, and 10th place in a third competition. So it really is helpful. There were other cases where, for example, there was a data set where the variable names were anonymized, but the winning team, they somehow realized that one of the variables was customer ID. It was anonymized, but they figured that out, and by knowing that was customer ID, they were able to surpass everyone else and get first place. There was another case where one person had a server with 1 terabyte of RAM, and he was able to treat a problem. He was able to solve it in a much more computationally advanced approach, and he got first place. Everyone else didn't have the kind of computation power. So this is usually how you win competitions. But to get second place, third place, fourth place, usually you don't need something that's kind of that unique.
Okay. Wow. Yeah. All right. Okay, we have 2 questions. Let's go to the first one. Hello, Dr. Qingchen. I'm a student who's actually majoring in math, but I have big data as my elective. But I have always been struggling with it. Do you have any advice on what are the basic skills or concepts that I need to work on or understand that you think is very important as a data scientist?
Yeah. So actually, there are 2 types of data scientists right now. One type is more what we would call analytics. The other type is more towards engineering. Now, based on what I've seen, for people who major in math or statistics, the primary challenge of working with data is in programming. Mm-hmm. You have to be able to program in either R or Python, preferably Python, in order to process data well. And I think in the industry that is a requirement. So if that's been a challenge for you, then I would strongly recommend just taking some time to learn how to program in Python. You don't have to learn how to program software in Python, just how to use essentially the pandas package and the numpy package in terms of data analysis, and that would be sufficient. But this is common. When I was doing my master's, there were 2 types of students in the program. There were students from a mathematical background and students from a computer science background. And we both had difficulties in different parts. So I was a computer science person, and I really was not able to solve the mathematical formulas that you need for machine learning. Some of my classmates who had a mathematical background, they had a very hard time programming. So we ended up having to help each other. But this is natural, and it just takes time to build up your skills in programming.
Okay. Yeah. All right. Hope that answers your question, Haika. Okay, let's go on to the next one from Azizi. Hi, I would like to know what is the usual setup of your machine, CPU or GPU, RAM, etc.
So when I first did competitions, I was using a MacBook Pro, had something like 16 gigabytes of RAM, just a Core i7 CPU without a GPU. At the time, that was okay, but with some of the larger competitions, I was running into difficulties. These days, I would recommend to have 64 gigabytes of RAM in a laptop or desktop. It turns out you can buy 32 gigabyte RAM chips now, so 64 gigabytes is actually quite easy to achieve. And then in terms of GPU, if you are not doing a deep learning, so if you're not working with natural language processing or computer vision, there is no need for GPU. Most methods are in CPU. But also, these days, the Kaggle platform provides a lot of powerful computing. So many of the competitions are actually what's called code competitions, where you have to write the code and submit it in Kaggle's servers as their notebook. So all you have to do there is just open up a Kaggle notebook and use whatever resources they provide. Everybody have to use that same resource. But even if you want to use just that, it is sufficient. They have very powerful GPUs, and they have more than sufficient CPU and RAM for you to use. So kind of your personal machine is not that important anymore for at least for Kaggle competitions.
Okay. All right, let's go on to the third question from Shamimi. Hello and good morning. I would like to ask if is it advisable to join few of the competitions to get into the top 4%, or focus on one competition and reach the top 10%?
Yeah, so I mean, good question. I think it depends. If you have the opportunity to do as well as possible in a competition, I would say go for it. Try to get as high as you can in a competition. But sometimes you'll find that you just don't have great ideas, so maybe you want to try a different competition, and that's fine, right? In the end, it has to be interesting for you for it to be valuable. So I would recommend if you find a competition interesting, then try to work hard at it. At some point, you'll reach a point where you try 10 ideas and none of them work, and that's natural, that's expected. But keep thinking, keep trying, and do the best you can in a competition as long as you find it interesting. If you don't find it interesting, then move on to another one. Yeah.
Okay. So hope that answers your question, Shamimi. Okay, the next one is from Fauzia. Hi, Dr. Wang. As for those who didn't win the competition, can we know the winner's data set and model and how they use it?
Yeah, so the data set is public, right? The data set is published as part of the competition. Everyone uses the same data set. Can you know the winner's models? It depends. So in many competitions, the winners actually open source their code and their approach. Sometimes they just write about their approach. Sometimes they do both. So feel free to go and look at some past competitions where, in the forums, somebody will say, first place solution, click into it, you can read about it. Often there's a GitHub link with the actual code. So, definitely look into it. It's not required, so it's not all the time that the winners will publish their models, but very often that does happen.
Okay. All right, so the next person from Rafiq. Hi, Dr. Wang. Currently, I am a data engineer. Did you have any advice on how to shift my career to data scientist? What I need to focus more on?
So that's a very good question. It kind of depends on what exactly you're looking for. So right now, like I said, in the field, there's the data scientist that's more on analytics. In those cases, it's more about understanding business and understanding statistics. The second type of data scientist is more like a machine learning engineer, which is mostly about building machine learning products, from a software engineering type of approach. So if you're currently a data engineer and you're interested in machine learning engineer, then you probably want to just learn some more about the machine learning models and I would recommend doing some Kaggle competitions. If you want to shift to more of the analytics type of data scientist, then I would recommend that you think more about products and think more about how you can use statistics to test the effectiveness of various product features or product changes. So that's my suggestion. If you're interested in machine learning related things, then definitely do Kaggle competitions, and it has helped so many people get into the field, get jobs and careers. I think it's still very powerful, but you do want to do it well. You do want to actually seriously work on these problems, and not only do you build skills, but you also build a nice profile for potential employers as well.
Yeah. So hope to see you on Kaggle, Rafiq. Okay, pretty soon. Okay, and the next question is from Azizi, Dr. Qingchen. For CV, NLP, and GANs, okay, GANS, would it be better to code in Python or Java? For example, DL4J for Kaggle competition.
So at this point, almost all Kaggle competitions are solved in Python, mostly because if you look at the public code, usually, if it's computer vision, NLP, or GAN, it is almost always in PyTorch or TensorFlow. And just because everyone is using Python, it's very easy for you to use Python as well, because you just start with their code and then start making modifications to it. Very rarely is Java used. I would say almost never now. And then R is also very rare. So I would recommend coding it in Python.
Java is becoming more and more obsolete, is it?
I'm not sure, actually. I think in traditional software engineering, Java is still quite common.
So between Python and R, Python is more used instead of R in the industry.
Yes. Yeah, because Python has many more big data type of packages already written for it.
Okay.
Yeah.
All right. Any other question? Can we have if there's any last question, because it's already almost 9:30, so to the end of the session. Any last question from the floor, from the audience? Can we have a photo session at the end? Okay, before after this last question. Any last question? Going once, going twice. Okay, all right. So thank you so much, Qingchen, for taking the time to give this very informative talk on your experience winning the Kaggle competition. We would like to work with you again in the future with our faculty. So can we have the audience to switch on their cameras and for a photo shoot, okay, so that we can commemorate this moment, okay? All right. So can we have the cameras on? All right. Any more people who are switching on their cameras? All right. Hello, Dr. Anna. Dr. Su, I think your camera is not switched on. You could switch on your camera. Oh, there you are. All right. Okay. Okay, any more people joining us for a photo shoot? You're most welcome. Okay, so I guess that's about it. Okay, so let me just do a print screen in 1, 2, 3, smile. Okay, another one, please. 1, 2, 3. Okay, that's great. Thank you so much for coming. Hope to I'll send over the evaluation form. Okay, through via email. Hopefully that all of you can fill it up so that we can improve in the future. And thank you again so much, Qingchen, for taking the time to be here. Thank you.
Yeah, thank you for inviting me.
Have a good day, everyone. Bye.
Okay, bye.
Thank you, Dr. Wang.
Thank you.
Thank you so much, Doctor.
Terlupa lah. Ji nak bagi evaluation form tadi. Kena melalui email kot.
Oh, kena email balik lah. Tak apa kan sebab ada mailing list tu.
Thank you so much. you